Okay, example 1 for lesson 15 involves solving the system of linear equations using the elimination method. Just on lesson 13 we dealt with the substitution method. This is the other technique. This is the one I prefer personally. I think most people do once they learn both methods. But again, I'm going to give you the warning that you need to know how to do both methods accurately, because there's times when the substitution method is the only one that works. Okay? And usually that's the one that I have to convince people to use after they've learned both. So, but anyway. You want both equations being xy equals number structure. I'm going to print this out for you so don't worry about copying it down. Xy equals number structure. That means like 3x plus 4y equals 2. 5x minus 7y equals 17. That type of structure. Decide which variable you wish to eliminate and perform multiplication or multiplication required to make the elimination work. Okay, for elimination to work, if I have 3x plus 2y equals 6, and 4x minus 2y equals 5, if I have that, elimination of y is very easy because the y coefficients are opposite. Positive 2y and negative 2y are opposite. If I were to add the equations together, 7x plus 0 equals 11. I can solve for x. Alright? And eliminating eliminating x here would not be possible immediately because 3 and 4 wouldn't cancel. I'd have to multiply by 4 and by 3 to get them both to be 12. One would have to be negative. Alright? So what you're looking for in step 2 is you want this picture here in your problem. If it's not there, you need to perform some multiplications. This times 4, this times negative 3. That would make 12x on the top one, negative 12x on the bottom one. Now the x's would cancel. But the consequence of multiplying this times 4 is this gets multiplied by 4, and this gets multiplied by 4. That got multiplied by negative 3, so this gets multiplied by negative 3, and that gets multiplied by negative 3. So if you have to multiply everything, but again, your goal is to get rid of something. So if I want to get rid of x, now the x's can go away. If I wanted to get rid of y initially, the y's could have gone away. All right? Once the variables are set up exactly right, again, 5y, negative 5y, 2x, negative 2x. They're exact opposites of one another. You simply add the equations together. X's add together, y's add together, numbers add together. The x's or y's, whichever you want to get rid of, goes away. You're left with a single letter. Solve for that letter. It'd be like 3x equals 15. X equals 5. 17x equals 2. X equals 2 17ths. All right? So it'll be something like that. Then, whatever you get for that answer, substitute into one of the original problems for that letter. So if x equals 5, go back to one of the original equations, change x to 5, solve for y. Once you get both answers, you write x, y as an ordered pair, and that's the end. All right? That's the elimination method. That's how it works. So let's go ahead and go through the process here, maybe if there's a problem. Okay? So, use elimination to solve this. Notice the order is good. X, y equals number, x, y equals number. Order's fine. If it wasn't, the first step I'd do is I copied to my paper, I'd rearrange it so it was that order. Alright? Next, I want to decide what to get rid of x or y. Let's go with Lexi. What do you want to get rid of, x or y?
X.
X, okay. That's what I would have chosen too. Here's why I would have chosen x. The signs are already opposite. Okay? They're not opposite numbers. 3 and negative 2 aren't opposite numbers, but at least one's positive, one's negative. That means I don't have to multiply by any negative numbers. If I were to get rid of y, they're the same sign, I'd have to multiply by a negative. So that was a good choice on Lexi's part. But getting rid of either one is legal. Okay, Austin, what do I need to multiply, or what do I need the x coefficients to become?
You need to become 6.
6, okay? 3 times 2 is 6, 2 times 3 is 6. Both numbers that are the coefficients can be easily made into 6 through multiplication. So times 2 on the top equation, times 3 on the bottom equation. So, if I do the top product, I'm going to get 2 times 3x makes the 6x we want to happen. The consequence of our action, again, what we wanted was 6x. The consequence is these two numbers have to change also. So we get plus 4y equals 46. The bottom multiplication, 3 times negative 2x makes negative 6x I want to happen. The consequence of that action is I've got to multiply that times 3 and that times 3. So I'm going to get plus 9y equals 6. The most common mistake people make in elimination is that they do the multiplication for the piece they need to fix, and they don't multiply everything else. So be careful that everything multiplies by whatever you chose. Lexi chose to get rid of x, and notice now we got 6x, negative 6x, we got opposites, now it's possible to eliminate. So, 6x minus 6x cancels. Opposite sign, subtract. Exactly the same number, you get 0. 0x is the same as 0, so that's just gone. 4y and 9y are both positive, so I add, I get 13y. 46 and 6 are both positive, I add, I get 52. Divide both sides by 13. Leaves me with y equals 4. Okay, my job is to get an ordered pair x comma y. So all I've accomplished so far is I figured out what y equals. So I put that in the right spot. The last thing I have to do is figure out what x equals. And I go back to either of the first two equations. So let me go back here, erase all this stuff. I just figured out that y equals 4. So I'm going to change either this y to a 4 or this y to a 4. Take your pick, doesn't matter. Either one of those equations will allow us to find out what x equals. So if I take this top one here, it says 3x. I don't know anything about x yet, so it stays 3x. It says plus 2y, 2 times 4 equals 23. All right? Again, y equals 4. Change y to a 4. Now I've got an x equation. 3x plus 8 equals 23. We move the 8 over to the other side. 3x equals 15. We divide by 3, we get x equals 5. The end. Sometimes students get hung up on, I don't know which equation I'm supposed to go back to. Okay? And I tell you it doesn't matter. If I had gone back here with y equals 4, I would have got negative 2x plus 3 times 4 equals 2. Okay, changing the y to a 4, everything else stays the same because I don't know anything about anything else. That's negative 2x plus 12 equals 2. Move the 12 over and subtract. I get negative 2x equals negative 10. Divide by negative 2, I get x equals positive 5. Same answer. If you get the right answer for y, you get the same answer for x no matter which equation you go back to. Pick one. Go back to it. Get the answer. All right? Don't get hung up on which one you're supposed to go back to because it doesn't matter which one you go back to. Make a choice. Go with it. Get the right answer. Move on to the next problem. All right? That's elimination. That's how it works. One thing I will tell you, suppose you get some answer like x equals 2/17. You got to go back and put 2/17 in place of x here, and all of a sudden you got to deal all these fractions. Let me give you an example like that real quick. 3x minus 2y equals 5, and 2x plus 2y equals 17. That'll work. Okay. So I'm doing that problem there. Does everybody notice that we can just immediately get rid of y the way it's set up? So we're ready to go immediately on elimination. So that's nice. 3x and 2x makes 5x. Negative and positive 2y cancel. 17 and 5 make 22. Divide by 5, divide by 5, I get x equals 22/5. Okay, so to go back and find y, I could do that substitution technique, right? The other thing I could do is I could get rid of x. If I multiply the top equation times a positive 2, and the bottom equation times a negative 3. All right, so the top equation times 2 makes the 6x. It also makes a negative 4y. It also makes an equals 10. The bottom equation, I get negative 6x. I get negative 6y. And I get negative 51. Those cancel. Negative 10y equals negative 41. Same sign add, negative's bigger. Different sign subtract, negative's bigger. Divide by negative 10, we get y equals positive 41/10. 22/5, comma 41/10.
Negative 41.
Positive. Two negative make a positive. Okay. Elimination can work both times if you wish. So if you get an answer you're not comfortable putting back into an equation using substitution to solve, I don't like fractions, so I don't want to put a fraction back in and try and solve that. Eliminating y finds x. Eliminating x finds y. You have the ability to eliminate twice to find both answers. That's legal also. Typically, though, you're going to get a nice integer answer for one. Substitution of an integer back in gets you a nice integer answer for the other. That's usually what you get for answers on these. But occasionally you get these fraction answers. That's, if you're not comfortable with fractions, not great with fractions, that would be the easiest way to handle a fraction situation. Because the only place I ended up with fractions was in the very last step. Divide by 5 got a fraction. Divide by negative 10 got a fraction. Both answers are found, and that's exactly the right answer. It would have been the same thing I would have found by putting 22/5 back into here and working it out. And it might be a little bit simpler for you to do that. So keep that in mind as an option. Do what you want to do it correctly, make a choice, stick with your choice, don't change your mind halfway through.